Hello everyone, I'm going to be going over homework number 8, number 27. A recent survey indicated that the average amount spent for breakfast by business managers was $7.58, with a standard deviation of 42 cents. It was felt that breakfasts on the West Coast were higher than $7.58. A sample of 81 business managers on the West Coast had an average cost of $7.65. Find the p-value for the test. So, let's go over to the board. So, as we stated, we're going to be finding the p-value, or p. Now, how we're going to do that is we're going to be using this formula. P is equal to 1 minus the z-value. So, I'll go more into that in a little bit, but let's write down what we know. We know that our null hypothesis is u is equal to $7.58, and our alternative hypothesis, u is greater than $7.50. We know that our standard deviation is 42 cents. We know that our n, our sample size, is equal to 81. We know that our x is equal to $7.65. What we don't know is z. So let's find z. So how we're going to find z is with this formula. X minus u divided by the standard deviation divided by the square root of n. So we already written down everything we know, so it's shown here. So we're going to plug everything in. It's going to look something like this. $7.65 minus $7.58 divided by 42 cents divided by the square root of 81. So I'm going to do the top part really quick. And it's going to look something like this. 0.07 divided by 0.42 divided by 81 divided by the square root of 81. So once we do this whole part in one fell swoop, we're going to get the z of 1.5. So with that in mind, let's go find p. So like I said, to find p, it's just going to be 1 minus the z-value. Now notice how I said z-value and not z, because we're going to be turning our z of 1.5 into its z-value. Now how we find that z-value is by looking over here on the SNCPT or the z-table, and right there as I circled, it's 1.5, which is going to be 0.9332, as shown here. So we're going to plug in 0.9332 for the z-value. It's going to look something like this. 1 minus 0.332 is equal to the p-value. So once we do that, our p-value is going to be 0.0668. And with that done, 0.668 equals p, which is our answer A. And here's all the work shown. Have a good day.